How do you establish workload identity in Kubernetes without hard-coding secrets or juggling expiring certificates? In this episode of KubeFM, Mai Nishitani, Director of Enterprise Architecture at NTT Data and AWS Community Builder, walks us through SPIFFE and SPIRE, open source standards that let clusters issue secure identities automatically. We'll explore why this matters for multi-cluster setups, zero-trust environments, and the future of cloud-native security. Special thanks to Testkube for sponsoring today's episode. Need to run tests in air-gapped environments? Testkube works completely offline with your private registries and restricted infrastructure. Whether you're in government, healthcare, or finance, you can orchestrate all your testing tools, performance, API, and browser tests without any external dependencies. Certificate-based auth, private NPM registries, enterprise OAuth, it's all supported. Your compliance requirements finally met. Learn more at testkube.io. Now, let's get into the episode. Great to have you with us, Mai. What are 3 emerging Kubernetes tools that you're keeping an eye on?
Yeah, thank you for having me on this podcast, Bart. Well, it's not really an emerging tool, but I've seen a lot of customers focus on Crossplane. So, managing cloud infrastructure through Kubernetes APIs is really elegant instead of like looking at Terraform files and kubectl commands separately. So you can define your entire stack as Kubernetes resources. And, coming from the AWS world, let's say if you wanted a Amazon RDS instance, then you can apply a YAML manifest. So basically it's like infrastructure as code, but native to Kubernetes and works well with GitOps. And I guess the second tooling that, speaking of GitOps, I like is Argo CD. And it really plays nicely with services from AWS, including Amazon EKS. So think of it as a deployment tool that watches your Git repos and automatically syncs whenever there's any changes, right, in your infrastructure as code back to your clusters. So I would say the beauty of Argo CD is that it flips that traditional CI/CD model on its head. And instead of the CI system pushing changes to Kubernetes, Argo CD runs inside your cluster and then pulls changes from Git. So it always matches what's in your repo, so don't need to wait around for that. Now, on the flip side, the UI is also usable for Argo CD. I guess it's rare for Kubernetes. So you can actually see your entire application topology. So you can roll back deployments with a single click and then debug synchronization issues without having to do a lot of kubectl commands. And last but not least, not really a tool, but more of a framework, SPIFFE and SPIRE. So I've seen this come up quite a bit of recent times. And SPIFFE stands for Secure Product Identity Framework for Everyone, and SPIFFE Runtime Environment for SPIRE. Now, it's almost like having a passport for your workloads. So instead of traveling between countries, your services are moving between different clouds and clusters. So you travel internationally, right? And your passport proves who you are, regardless of which country you're in. So SPIFFE does the same thing for workloads. And what I love about it is that with Kubernetes, right, with the service-to-service authentication has been pretty messy. So you've got service accounts for in-cluster stuff. You've got iron roles for AWS, whether it's IRSA, or if you're using Amazon EKS pod identity, you might even have some custom JORT tokens for external APIs. So, it's like having different forms of ID for each border crossing. And SPIRE is the implementation part where the passport office is what it actually issues and manage these identities for you. So basically, having that passport systems that works in every country so that your services can securely communicate to each other is, I think, very useful.
And Mai, for people who don't know you, could you just give us a quick introduction about who you are, what you do, where you work?
Sure. So I'm a Director of Enterprise Architecture at NTT Data and a former AWS Senior Solutions Architect, and a current AWS Community Builder in containers with all 14 AWS certifications, and I'm a golden jacket holder as well. So back at AWS land, I used to look after 200 plus services. So at the moment, if you replace those 200 plus services with 200 plus vendors across cloud, network, security, traditional data centers, hybrid cloud, data and AI as a full stack provider, it keeps me on my toes every day. And how did I get into cloud native? So I got into AWS 11 years ago. So I was a systems administrator looking after VMware. And that's when my whole love affair with AWS started and where I met my current romantic partner. So he was actually the application vendor who hosted applications in AWS. So it was quite monolithic at the time. So think EC2s and RDS. And our CIO was keen on deploying his application across the organization, but he just came back from a conference and got told that cloud was insecure. So he told everyone to shut down anything related to cloud. And so this application vendor came into a meeting and was flustered and he was like, oh, I got to move everything from the cloud to on premises. And guess who was looking after VMware? It was me. So I was tasked with setting up a LAMP stack. And from there, I learned all about AWS from there because, why is the CIO so scared of AWS, right, at the time? So I decided to get certified with the Solutions Architect Associate certification. So that's where my career progressed into cloud.
Very good. And what were you before cloud native?
Yeah, so before cloud native, I was back in infrastructure. So back in the days when IBM was the number one largest tech company across the world. So I was inbound tech support. And this is where I learned all about troubleshooting. And I became from support, tech support, to systems administrator, to desktop support, to solutions architect, cloud engineer, then solutions architect, and now enterprise architect. I spent quite some time in the infrastructure space. Now, another thing that I guess, what do I miss from, I guess, back in the day? So tech is now a commodity. Now, everyone can be an expert using ChatGPT or other tools to educate themselves, which is a good thing. But on the flip side, I do miss being that anomaly, being that nerd. And, back then it was quite uncool to be techie. So, yeah, I feel kind of strange that we're the cool kids now. And what have I found these days? That some of these cool tech concepts do repeat. So, take, for example, like if you compare them to jeans, right? So trends come and go. Right now, you have your baggy, wide-legged jeans, and soon enough, you're probably going to see skinny jeans back in fashion. So it's the same with tech. And not everyone, now everyone's talking about like agentic AI and AI everything, right? But if you rewind back 11 years ago with the Gartner hype cycle, natural language question and answering was peak technology. So now it's just rebadged as agentic AI and generative AI, which is easy for people to consume. It is the same concept. It's just now rebadged. But one thing is constant, and that infrastructure runs these AI services, right? So if you have infrastructure, there's going to be upgrades, as people in the audience know. So if there's upgrades, there's going to be deprecations as well as new features, right? And things are going to fail. So you're always going to need someone that looks after the infrastructure.
And the Kubernetes ecosystem moves very, very quickly. How do you stay up to date? What resources work best for you?
Yeah, so a variety of things. I go to a lot of events, including some of the CNCF ones, which is coming up. So CloudCon in Sydney, mid-September, I'll be there. And a lot of books. So Gregor Hope's platform strategy will be relevant for this audience here. So he dives into what does a typical enterprise platform strategy might look like and how do you build that out. And being part of a community really helps as well. So I'm part of the AWS Community Builders program, and I have been to Community Day, so AWS Community Day. Shout out to Alan, Dimitro, Stephen, and Lucy, and the AWS user group as well. So definitely go check out one near you. And podcasts like this one, as well as others, and conversations with those in the community. Definitely talking to those that are DevOps engineers on a day-to-day basis. So shout out to the two Olgas that I know in the DevOps space.
Very good. And you also mentioned, just as a bonus question, you mentioned that you've also hosted your own podcast. Can you tell me about that?
Yeah, sure. So the AWS She Builds Tech Skills podcast focuses on women who are uh, really, doing some really cool things in tech, especially in AWS. That podcast is still ongoing with our North American counterparts. So please go check it out if you want to see some awesome women in action.
Very good. And special shout out to one person who I imagine we have in common, Farrah Campbell, who's very active in the AWS space. Wonderful person doing lots of great community work. If you're not following the stuff that she's doing and you're interested in this kind of stuff, highly recommend it. Last but not least, before we dig into, the crux of the matter here with what you wrote about, Mai, if you had to go back and give yourself, one piece of career advice, what would it be?
Yeah, sure. So this applies from back in the day because at the moment, I know the job market is a little bit tight at the moment. But if I could travel back in time, I would say don't stay in one job because it just gives you a paycheck. I should have challenged myself and I should have taken some risks while I could. And it's okay to fail, right? I should have just created a startup or several startups before the dot-com bust. Yes, I am that old. And currently we've got the AI boom, so why not get on top of it if you obviously if you don't have a mortgage and if you don't have any dependents. So yeah, yeah, definitely take more risks.
I like that. If you do decide to create a startup, let us know. We'll be making lots of noise about it. Now, to dig into what we want to speak more about in depth today, you wrote an article that we found in our monthly content discovery at LearnCube called Scaling and Troubleshooting Amazon EKS Just Got Easier with MCP on Anthropic Claude. So we want to dive into this more. You've been in systems administration for over 15 years at this point, starting with tools like Nagios. How has the landscape of infrastructure management fundamentally changed from those early days to today's Kubernetes-centric world?
Yeah, sure. So, starting back in the Nagios days, so I had to compile that from source, and it wasn't easy at the time. And plus, it was running on a VM. So, um, you know, was it highly available? No, it wasn't. Was there anything to check the checker if that actual server failed? No. So I wasn't even thinking in that kind of way. I was just really focused on getting Nagios running. So very manual at the time, and even going back further, right? If anyone remembers patch nights, so back then we used to run manual patch nights after Patch Tuesday in US time. So that ended up being on Wednesday or Thursday Australia time. So what happened was there were pizzas so that all of these sysadmins stayed up all night patching servers. So click opsing into the wee hours in the morning because there was no automation back then. Right now, there's a lot of tooling available in AWS land. There's Systems Manager, Patch Manager, right? Plus other tooling out there that will help you automate that where it makes sense. Now, one thing to note is, if anyone knows the book, The Phoenix Project, right? I can't finish that book because it gives me PTSD. That's because all of these on-prem services break in that book. Spoiler alert, and that kind of matches my experience, right? Being on call and having a SAN fail in the middle of the night, and I couldn't remote in, right? To take a look, so I had to actually come in and restart it. Still didn't restore itself because it turned out to be a firmware update issue. So, and there definitely wasn't any documentation around this cryptic error. So we were heavily reliant on the vendor to fix things. And, not to mention the go-to, which is Stack Overflow, always used to be closed due to duplicate issue or, maybe someone solved it without an actual solution, which is really frustrating. So, you know, breaking things in production, obviously not on purpose, and also fixing it under time pressure without documentation. If you haven't experienced those things, you really haven't lived as a techie, I reckon.
You mentioned that microservices were supposed to make life easier for DevOps engineers, but they've introduced their own complexities. What's the reality of managing Kubernetes at enterprise scale versus the promise?
Yeah. So if you're running Kubernetes personally in your home environment, that's definitely no comparison to enterprise grade critical workloads. Now, version upgrades can be cumbersome because you need to know not only what's new, but what's going to be deprecated because you're going to have to change your application code, right? So, what I've found in large organizations is that even though they say DevOps, in theory, there are DevOps teams and there are application developers. And usually, these teams in large organizations, unless you're fairly advanced in this space, can be quite siloed and throw in the traditional infrastructure team and the security teams in there as well. So, with the enterprise scenario, getting approval from all of these different teams, getting everyone to plan ahead and know exactly what to do to prepare for an upgrade is where it falls short and where a lot of customers struggle in this space. So the coordination and planning is the difficult part. The tech is the easy part.
Yeah, that's actually an answer that we get quite a bit. When we spoke to someone, Bob Wise, who's currently at NVIDIA, but was, OG Kubernetes, about the biggest challenges around Kubernetes, he echoed exactly what you just said, that as much as we're talking about technical challenges, the human part of it is actually the most complex thing to coordinate, about getting the right people to be doing the right things and focusing on the real priorities, and also which technologies are really responding to the problems that are faced by a particular organization. So you described a real crisis scenario where a team was frantically trying to upgrade Kubernetes versions before a forced production rollout. It sounds like a nightmare scenario many folks have faced. What made that situation so challenging?
Yeah. So if I rewind back to that time, so there was an organization that had outsourced management of their Kubernetes clusters to a third party under a managed services agreement. So the Kubernetes version from the product perspective was going end of life. So there were a lot of notifications to the account owner's email. That got ignored due to alert fatigue or lack of proper handover from the customer to the new managed services provider. So what happened was the customer called us at 2 weeks out from the end of life date. So we were able to give them an extension of one more week. However, the problem was that we couldn't continue to keep extending this customer as an anomaly because it was going to be a security risk if we had the customer on a different, lower version compared to everyone else across the globe. So, what the customer realized very late was that their application code needed to be updated with the correct software dependencies that obviously didn't include the deprecated components. Luckily, they had non-prod, so we could actually test with the provider that was helping the customer. However, they didn't have the context behind what the workloads were doing, so we definitely needed to have the customer involved. So it was a team effort to try to get this upgrade happening from all different layers, right? And what didn't happen that probably would have helped the team was around detecting, like, so there's tools like Pluto to help detect any Kubernetes API versions that could be deprecated. Um, Obviously, refer back to the Kubernetes API reference and the release notes. There wasn't enough of that happening before the end of life date. And looking at what are the cluster add-ons and compatibility around that, like ingress controllers and monitoring solutions and storage provisioners as well, and what's compatible with the new Kubernetes version as well.
This brings us to the elephant in the room. Kubernetes administration is fundamentally changing with AI assistance. You've been experimenting with MCP servers connected to EKS. Do you think this evolution is for the better?
Yeah, so from the AI assistance point of view, you get to learn a skill really quickly, so you can supercharge your training and enablement from an individual perspective, right? So, it wasn't that long ago when we were looking at Google and Stack Overflow, Medium and Reddit, and, we all know about the not having the correct answers or no answers in there, right? But, it's probably the same as DevOps, right? So everything could be automated to a certain point. And I've seen DevOps engineers automating themselves out of a job as well. But um, it is similar in that you still need to steer the systems right. So for me, I'll give an example where I was playing around with Claude to build a web application that's hosted on Amazon S3. So Claude suggested that you should just create a public S3 bucket, which in the early days that was acceptable, but now best practice is to host it on private S3 buckets and have Amplify, so AWS Amplify for hosting. So obviously it didn't have the latest information, but I had an inkling around that could be wrong. So I did my verification, and yeah, turned out it was some outdated information that Claude was providing me. So if you think something isn't right, do your research and refer back to the vendor documentation. That's a really good way to start if you're dealing with vendor products, or obviously the CNCF docs, or if there's any Git repos, go to the vendor aligned Git repos and make sure they're up to date as well.
Now, let's talk about Amazon EKS Auto Mode, which you describe as an improved Fargate. How does this fit into the broader trend of abstracting away infrastructure complexity?
Yeah, so EKS Auto Mode is really great because it learns from what didn't work well with Fargate. Now, Fargate was really huge when it came out, serverless containers. It's great in theory, but in practice, especially for EKS and Fargate, there were some limitations. So you couldn't use certain storage types. Networking got tricky, and yeah, you could forget about running daemon sets, right? Or you couldn't really run GPUs. Now, EKS Auto Mode takes a different approach. Instead of like hiding the infrastructure from you, it's all about managing the boring and repetitive stuff so you don't have to do it. You still get EC2 instances, and AWS handles the cluster upgrades, the security patches, and bakes in some of the best practices automatically. So it runs the following out of the box, including Carpenter, so it helps you auto scale the compute for your cluster, the AWS load balancer controller, so it helps you expose your Kubernetes services via the Elastic Load Balance integration, EBS CSI, so it lets your pods use EBS volumes as persistent storage, the VPC CNI, so it gives a pod its own VPC IP address so it can communicate directly with other AWS services, and also EKS pod identity agent, so handling AWS credentials for your pods so you can securely access your AWS services. Yeah, so the day two operations is what it helps with in terms of EKS Auto Mode.
You discovered an MCP server that can connect Claude to Kubernetes clusters. For folks out there that might be unfamiliar with MCP, can you explain what this protocol is and why it's significant for DevOps workflows?
Yeah, sure. So MCP, which stands for Model Context Protocol, is basically like a USB for AI tools. So before USB-C, every device had its own weird charging cable, and if anyone remembers the mini USB, and I still have a drawer full of cables sitting there in case I need it, and I'm sure it's the same for everyone, right? So integrating with AI with different tools used to be you had to build a custom integration. So if you wanted to work with your monitoring system, that's another custom integration. If you wanted to integrate with your CI/CD pipeline, you need to create another one. So it's quite messy to create these one-off custom integrations to, one to build and also continue to maintain. So MCP standardizes how AI communicates with these external tools and data sources. And when I found this MCP server for Kubernetes, it just works with Claude. So Claude can now, behind the scenes, kube control on your behalf. So it can check your pod status, it can check out your logs, and help with your troubleshooting, all through this standardized interface. And what's really great for DevOps is that it creates a really consistent way for AI to plug into your entire tool chain. as I mentioned before, monitoring your deployment and your infrastructure as well. So yeah, so it's almost like moving from the early days of APIs where everything was custom to having that universal protocol that makes AI integration way more practical and easy.
And walking through your demo, you were able to ask Claude about your EKS setup in natural language, and it provided detailed configuration information. How accurate and useful was this compared to running kubectl commands manually?
Yeah, sure. So instead of me having to remember if it's kube control get nodes or kube control get pods and all the switches, I could just ask Claude to tell me about my EKS cluster in detail, and it ran all the right commands behind the scenes for me. And Claude automatically checked my nodes, my namespaces, my deployments, services, and storage classes, and even spotted the game that I deployed from the EKS Auto Mode tutorial. And that gathering that kind of information would normally take at least 6 or 7 different kube control commands, and Claude was able to do that in one hit. And the accuracy was almost spot on because, obviously it was running kube control under the hood, but you know, instead of passing through like lots of YAML output, it gave me a summary of what it was running, where, and it'll even picked up on the bottle rocket operating system as well. So, and also identified node pools as part of the managed configuration. Now, where I found something that was interesting is I wanted to make sure that I can actually test Carpenter, right? And I said, let's scale to a third node, and Claude figured it out, and it created a resource-intensive deployment to trigger the autoscaler. So it didn't blindly increase the replicate counts, and it understood that the existing pods were too small to force that new node. So it created something that would actually need more resources. Now, when I said that we don't need the resource-hungry deployment anymore, it actually read between the lines and that it scaled back down. So it automatically deleted the deployment and monitored as Carpenter deprovisioned the extra node. So I would call it operational intuition and not just randomly executing commands.
Now, one interesting moment was when Claude seemed unsure about whether you were running auto mode or EC2 instances. How do you handle these AI uncertainty moments in production scenarios?
Yeah, so that's a perfect example of why you can't just blindly trust AI outputs in production, especially, right? So I know Claude was trying to help me troubleshoot and just made an assumption. And in that moment, it wasn't quite right. So it's great at guessing and generating information, but they don't actually know your specific environment unless you specifically provide that information. So you're working off probability and training data and not necessarily real-time cluster state. So that uncertainty was actually valuable information, right? And in production scenarios, I treat AI suggestions like recommendations from a really smart colleague, right? They don't have access to my information, but I will still take their guidance, but they might not know the context behind it. So it's almost like the zero trust principle, where you say, never trust, always verify. Now, um, you know, and again, falling back to the kube control commands is definitely good to have the fundamental understanding as well. So I would use AI as an assistant rather than a replacement of your knowledge. And being that 10x engineer is, I think, using AI, so increasing your productivity rather than replacing your critical thinking skills is where we should be focusing on.
It's a very nice assessment because of all the uncertainty and sort of feeling threatened about AI, but really that it's complementary, just helping you to be more productive. And you tested Claude's ability to scale nodes and trigger Carpenter. Then the fact that it handled this seamlessly and scaled back down gracefully suggests AI understands not just commands, but operational best practices. What are the implications of that?
Yeah. So, yeah, at that time it really surprised me, right? So it wasn't just that Claude can run the kube control commands, it actually intuitively understood the operational flow. So what it's like to check the current node utilization first and create a workload that actually triggered Carpenter's scaling logic, and it remembered to actually scale back down. So scaling back down is really important. I've come across customers that, they didn't, they left non-prod environments running, right? And it doesn't just encompass like Kubernetes environments, but non-prod servers, for example, right? They just kept it running, and that ends up costing quite a bit. So it's great that Claude automatically thought, okay, so we've proven this now works, so let's scale back down so we're not actually wasting money. So that's not in your typical Kubernetes tutorial, and that's a collection of operational wisdom. So it's great that AI seems to be absorbing some of these best practices from the collective knowledge of thousands of engineers, right, who've written about Kubernetes operations. And it's not just executing commands, so it's learning the why behind the commands. So imagine thinking about like onboarding junior engineers where AI isn't just helping them run commands, but they're actually teaching them proper operational hygiene and preventing those 2 a.m. production incidents where someone runs a command without even thinking it through. But here's what gets me a little bit worried. It's that AI can encode good operational practices, but on the flip side knows about the bad operational practices as well. So it's going to depend heavily on the human running it. So always need to have a human in the loop.
Now, this raises a very provocative question that you posed, and this could be a bit controversial. I'm sure we'll get some really nice material out of this for our clip, which we will provide in its full entirety, so it's not, sound bites that will be misleading. But will Kubernetes certifications like CKA and CKAD become obsolete if AI can handle most administrative tasks?
Yeah, sure. So it's an interesting question because, if Claude can kube control better than most engineers with CKA, what's the meaning of a certification, right? So I think the value is shifting from can you remember the exact syntax for a complex kube control command to do you understand why you're running that command and what could potentially go wrong? So AI might be able to execute a rolling update, but does it understand the business impact if that update breaks your payment system? So I think your certifications would focus more on the strategic stuff, so architectural decisions, security trade-offs, understanding failure modes, the things where you need like real context around your business and systems that AI doesn't have. So with CKA right now, it might be fix this broken cluster under time pressure, and it can get quite, difficult, right? But I think it should move to, here's a business requirement, design a Kubernetes architecture that meets these compliance, performance, and cost constraints. I'm thinking the well architected from an AWS perspective, but AI could definitely help with implementing that design, but it won't be able to make those judgment calls for you. So some of the human skills that would help would be understanding those organizational dynamics, negotiating, also translating that business need into technical requirements and saying, even pushing back to say, hey, Kubernetes does not solve everything, right? Maybe you can look at a serverless solution here, and I'll probably get flack for saying serverless in this podcast, but yeah, so definitely need that element of human decision making.
Great points. And for all the serverless haters, we'll see you on Reddit. So we're not when the comments start coming in. Now, this brings up a concerning trend that we've noticed at Kube Careers. Kube Careers is a site that we run where we aggregate all the different jobs in the Kubernetes ecosystem so that it's easier for people to find companies that are looking to hire. But one of the things that we're facing is that we're struggling to find junior Kubernetes roles to list. And across the industry, companies seem to be hiring fewer junior engineers in general, partly due to AI capabilities. You've lived through the evolution from manual administration to AI-assisted operations. What worries you about this trend? And what happens in 10 years when we potentially have a generation that never learned the fundamentals?
Yeah, so you raised a really good point, Bart. So we might be creating this massive skills gap where we have senior engineers who've learned on bare metal and junior engineers who only know how to prompt AI, but nobody in the middle that understands both worlds. So I've lived through the transition from manually partitioning disks and ClickOps and compiling from source to deploying via infrastructure as code these days. And, that abstraction is good. Although I don't miss dealing with SANs and bare metal hardware. But here's the thing, when those abstractions break, you need someone that understands what happens underneath the hood, right? AI is just another layer of abstraction. So it's going to break in weird ways and everything fails all the time. So what worries me is that, the struggling with fundamentals phase that builds that troubleshooting muscle. So if you've ever suffered the fate of like having firewall rules blocking traffic to and from source and destination, I had to go through the full OSI layer to see where the problem is, right? And I still believe troubleshooting is the key to success in your tech career. And even in the cloud world, IAM policies always still trip me up, right? So, um, how do you scope down the permissions and have least privileges? But on the flip side, you don't want to have admin access to everything, right? So, this suffering actually taught me about some of the failure modes that don't actually show up in your, even when Googling. So if junior engineers don't go through that process, then they wouldn't even know where to start. And back in the Googling days, you had a combination of keywords that gets you to eventually to that potentially that problem, but sometimes there might not be that documentation that helps you, right? And it's the same thing 10 years from now. So we might even have that scenario where all the senior engineers are going to be retiring and we're going to be left with people that can actually just prompt AI really well, but they might panic when they need to SSH into a node and debug something that AI doesn't understand. So that's something to maybe not look towards, but maybe we need to start educating the folks early.
Great points all around. Building on that, when you were frantically troubleshooting the Kubernetes upgrade crisis with your team, it was human understanding of the underlying systems that ultimately saved the day. If future engineers primarily interact with Kubernetes through AI interfaces, how will they handle the scenarios where AI doesn't have the answer? I know you touched on this previously, but maybe take this a bit further.
Just randomly running kube control commands under the sun, trying to understand and troubleshoot a broken upgrade without understanding the workload, that is a nightmare scenario. So what saved the day? It wasn't prompting for kube control commands. So it was collaborating with engineers from the customer end, the managed services product provider, and from the vendor side who understands the interactions between the applications, some of the network policies, the storage configurations, and how different Kubernetes versions change those behaviors. So this is why I worry about the generation of black box engineers. So if your primary interaction with Kubernetes is asking Claude to run commands from you, what happens if there is that weird edge case when the application is failing in a way that doesn't match, uh, an AI output? So, you know, this is when the symptoms are so specific to your environment, and every customer environment is different, right? So, another issue is that AI can make day-to-day operations smoother, but it might be complacent around keeping up to date with the latest um, feature additions and deprecations. So, again, CNCF documentation around the latest release notes, you need to refer to that and not Claude in this, or Claude, or any other AI tool in this case, because again, the human element is super important to always verify.
Mai, you've painted a picture of using this technology during those dreaded 2 a.m. troubleshooting sessions when your brain isn't working optimally. How could AI assistance transform crisis management in DevOps?
Yeah, so definitely, at 2 a.m. when you're troubleshooting, having an AI tool help you is definitely a game changer. So, when you're half awake, production is down and you're staring at logs, right? And it's usually, you're rubbing your eyes and lines and lines of logs, and the coffee isn't kicking in anymore. So this is where having AI as your expert gets really interesting. So obviously it doesn't get tired, it doesn't panic, it doesn't check the obvious stuff. Uh, and how many times have we spent an hour debugging and going through logs, thinking of the weird, complex edge cases where we forgot to check the fundamentals, and the actual solution was staring us right in our face. So I would picture AI as being that methodical training partner. Sorry, not training, troubleshooting partner, right? So you might be seeing like 500 errors. So, it might ask you to check the ingress controller logs first and then work your way back through the stack. So it gives you that systematic approach when your brain doesn't work at that time. And, AI could help with the communication side as well. So what happens when there's an incident? You need to write a PII or post incident report, right? And that's the last thing you want to do before going to bed after hopefully resolving that issue. Maybe it's a temporary workaround, but having an AI tool help draft the postmortem while the details are fresh, and that would definitely help you in going to bed early, right? And getting that update out to the stakeholders where it's needed.
And now, from a practical standpoint, what are the current limitations of using AI for Kubernetes operations, and what should teams be cautious about when implementing these tools?
Yeah, so AI for Kubernetes operations is amazing, but again, not ready to let loose in production yet without guardrails. So AI hasn't got that real-time awareness of your cluster state. It might even suggest scaling up nodes when you're already at capacity, or maybe restarting a pod that's currently handling critical traffic. So it's working off patterns and documentation, and it's giving a guesstimate as to what would be best for your clusters. So again, the human judgment is super important. The permission side of things is really important as well. So if you're giving AI access to kube control, you really need to be thoughtful about RBAC. So I've seen demos where people actually give it cluster admin just to make it work, which is not best practice. So you need to think about scoping down those permissions hard, maybe give it read only for most things and write to specific namespaces or resource types. And again, the version compatibility side of things. So a command that worked in Kubernetes version 1.20 might break in 1.28. So not great at keeping up to date to which features were deprecated when, and the newest releases might not be in its training data unless you give it that data. Yeah, so definitely, once again, coming back to the human fundamentals and troubleshooting.
Now, looking up the broader intersection of DevOps and AI beyond just Kubernetes, where else do you see AI making the biggest impact in infrastructure operations?
Yeah, so some of the places where AI is starting to be productive are around monitoring and incident response. So instead of setting up those alerts that lead to alert fatigue, it can actually sift through that and understand what normal patterns look like for your specific workloads and then flag genuine anomalies. And security scanning is another big one. So it's not just for CVEs, it can actually spot any suspicious patterns within your infrastructure configs that a human might miss, like, hey, this service account has more permissions than it actually uses, or this network policy change opened up a path to your database. And infrastructure as code is getting more sophisticated. So AI can review your Terraform and not just check syntax, but understand your architectural anti-pattern patterns as well. So you might be creating a single point of failure here, or this setup is going to be quite expensive at scale. So yeah, again, coming back to the routine or operational stuff, to get rid of the boring things like log rotation, certificate renewals. I've had issues with certificates back in the day, and basic health checks and all the things that a lot of engineers usually get stuck with. And that frees humans up to focus on more of the creative and strategic side, including architectures and actually solving business problems instead of babysitting these routine jobs.
For DevOps teams and platform engineers who want to start experimenting with AI assisted operations, what would you recommend as first steps?
Yeah, I would always recommend starting small and with guardrails, and don't jump straight into having AI manage your production clusters. Even though I've got a demo that looks cool with Claude, uh, always non-prod first, and that should be obvious. And what's low risk could be, helping you write and review infrastructure as code and have it generate Terraform modules or Kubernetes manifests. Obviously, review them like you do with any kind of pull request. So it's a great way to think to see how AI thinks about infrastructure patterns and verify again. And documentation is a really great starting point. And AI is fantastic at looking at your existing runbooks and making it better, or even generating documentation based on your current config as well. And what I would suggest is Amazon's spec-driven code generation tool called Kiro as well. So Kiro would help with generating user stories for specific projects based on your prompt. So I've been using Kiro, and it's been really fantastic in getting that baseline around gathering requirements from different stakeholders that need to be in a project. Because I believe the technical side is the easy part, but it's the gathering the requirements to start a project is the difficult part. And anything that touches production, make sure you can start read only. So help so AI can help with interpreting logs and looking at metrics, suggesting troubleshooting. So again, with the operational excellence part, AI can definitely help.
Now, as someone who's been through the evolution from manual system administration to AI assisted operations, what's your vision for the future of DevOps? Will the role fundamentally change? And how do we ensure we're preparing the next generation properly?
Yeah, so I think we're heading towards a world where like DevOps engineers become more like architects and strategists. And that is why I'm investing heavily on the architecture track. And I feel that we're going to move towards being an orchestrator of AI agents. And the really boring stuff like patching systems, deployments, and basic monitoring, that may be automated away by AI, which is great because who enjoys staying up for a routine deployment at 2 a.m.? And that means that the human role shifts upwards. So we're going to be the people who will be designing systems, make those architectural decisions, and understand the business requirements and help to translate that into infrastructure strategy. So it's more moving away from how do I configure this load balancer to what's our disaster recovery strategy for a multi-region outage across multi-clouds. So the challenge is so that we don't lose that foundational knowledge that makes that higher level decision possible. And you can't design a resilient system if you don't understand how these different components fit in together. And as Andy Jassy likes to say, there's no compression algorithm for experience. So I would say a future DevOps engineer is someone that can rapidly prototype infrastructure with AI, but also be able to dive deep when AI suggests that something is wrong. So they're comfortable in saying, hey, Claude, can you help me implement this architecture? But, they designed that with some understanding of some of the trade-offs.
Now, Mai, what's next for you?
Yeah, so I want to get more comfortable having more strategic discussions with some non-technical folks like the chief financial officer, the CEO, the COO, and being able to continue to translate complex technical ideas into simpler language that non-technical folks understand. And being able to explain it like I'm five is definitely important for understanding that concept yourself as well. And I've been heavily investing into I love the CNCF side of things in FinOps. So I'm trying to get FinOps professionally FinOps professional, and hopefully I'll get there. And another thing is books. So I still continue to read books. Gregor Hope's Software Architect Elevator is really useful if anyone wants to understand how to talk to different levels of audience, from the technical engineering teams to the non-technical folks up in the exec layer.
And how can people get in touch with you?
Yeah, you can reach out to me via LinkedIn, and I'll be posting about any content around mostly containers and AI, sometimes drones, and about events that I'm attending. So if you see me out there, come and say hi. And thank you very much for having me, Bart.
Wonderful to have you, Mai. Look forward to crossing paths with you again in the future, whether it's online or in person. Keep up the amazing work, and we'll be in touch. Take care.